Welcome to the second video of Module 2. We will discuss elements and compounds in this video. The learning outcomes for this part are: identify the elements and be able to use the periodic table, and differentiate between ionic and molecular compounds. In the first part of Module 2, we said that elements are the building blocks in chemical reactions. We cannot break or separate the elements using standard chemical reactions. So what are these elements and where can we find them? If you look at the last page in your lecture notes, you will see the periodic table. This table contains the elements that exist in nature, and it is organized in order of increasing complexity. Make sure you familiarize yourself with this table, as you will need it a lot during this course. In this table we can see the abundance of the elements on Earth. Number 1 is oxygen with almost 50% abundance. Then comes silicon, aluminium, and so on. The names of the elements originated from different sources, but mostly from Greek, Latin, or German words. Each element has a symbol that we use when writing chemical reactions. There are 3 rules to consider when writing the symbols of elements. First, symbols have either 1 or 2 letters. Second, if 1 letter is used, then it is capitalized. For example, the symbol for hydrogen is H, and carbon's is C. Finally, if 2 letters are used, then only the first is capitalized. For example, calcium's symbol is Ca, and chlorine's is Cl. There are no 3-letter symbols. Also, it is very important when you have 2-letter symbols to write the second letter as a small case, otherwise it might confuse people of what element you are referring to. We will cover some examples in the tutorial session. In this table you can find some of the more common elements and their respective symbols. You can pause the video and familiarize yourself with these elements. Let's introduce the periodic table, which is a special table that contains elements that we find in nature. The elements are organized in the periodic table in a certain order. For example, the position of the element is related to the electronic structure, which determines the properties and the group of elements. The shape of the periodic table is not similar to a regular table. The horizontal rows are called periods, and the columns are called groups, which usually contain elements with similar chemical characteristics. This is the periodic table you will find in your textbook. The table is divided into groups. For example, the first block of the table is called Group A, or Block A. Then comes Group B, and after that comes Block A again. The groups have different names too. For example, the first group, 1A, is also called the Alkali Metals group. The second group, 2A, is called the Alkaline Earth Metals group. Group B is called the Transition Metals group. The transition metal group's properties are more complicated than Group A's, and thus it will not be covered in detail in this course. The focus will be mainly on the A groups. On the other side of the table, we have the halogens group, Group 7A. And the last group, 8A, is called the noble gas group. You can notice that there are 2 different numbers on top of each group, so the groups can be numbered as 1, 2, 3, 4, up to 18, or 1A, 2A, 3B, 4B, and so on. So let's learn some elements. Group 1A contains the following elements: hydrogen, then comes the alkali metals such as lithium, sodium, and potassium. Group 2A, or what is called the alkaline earth metals, contains beryllium, magnesium, and calcium. Group 3A includes boron, aluminium, and gallium. In this group, aluminium will be the most important element. In group 4A, carbon is a very important element, especially in organic chemistry. Also in 4A is silicon, which is used as a semiconductor in computer chips. In group 5A we have nitrogen, which is a very important gas as it forms almost 80% of the air that we breathe. We also have phosphorus and arsenic, which is very poisonous. Group 6A contains oxygen and sulfur. In group 7A we have fluorine, chlorine, and bromine, all of which are very important elements, and we will use them a lot in this course. The final group, 8A, is called the noble gas group. Helium is currently used to fill balloons as it is lighter than air and safer than hydrogen. You only need to learn the important elements from the periodic table. You also need to remember where to find the alkali metals, the alkaline earth metals, the transition metals, the halogens, and the noble gases. The elements in the periodic table can be classified into three groups: metals, non-metals, and in between there are a few elements that are called metalloids. Metals have generally high melting points, and they can efficiently conduct both electricity and heat. On the other side, non-metals have relatively low melting points and are generally poor conductors. The properties of metalloids are between the metals and non-metals. Therefore, metalloids are used for their important properties. For example, germanium and silicon are very important semiconductors that are used in computers. Remember that compounds are made of elements. When two elements come together in a chemical change or chemical reaction, they form a compound. Compounds have fixed ratios. For example, a water molecule has the ratio of 2 hydrogen atoms and 1 oxygen atom. So water forms from 2 elements but 3 atoms. Compounds, unlike elements, can be decomposed chemically into simpler substances, that is, into simpler compounds and/or elements. Writing the chemical structure for compounds requires writing the atoms and number of atoms in subscript font. For example, water's molecular formula is written as H2O. The digit that indicates the number of atoms in a compound always has to be a whole number. It cannot be a fractional number. For example, sulfuric acid has a molecular formula of H2SO4. So in this compound there are 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. So as you can see, the number of atoms are whole numbers, and you will never find fractional numbers such as 0.5 or 1.2 in any compound's formula. There are 2 types of compounds, molecular and ionic compounds. We will explore those in detail next. There are 2 types of compounds, molecular and ionic. The main difference between the 2 types of compounds is the forces of attraction that hold the molecules together and form the compound. Let's start with the ionic compounds. These compounds are formed from ions. Ions refer to atoms that have either a positive or negative charge. The charge comes when the atom either loses electrons or becomes a positive ion, or gains electrons and becomes a negative ion. Let's consider the following example. Sodium becomes positively charged because it loses 1 electron and is called a sodium ion. In the same manner, chlorine becomes a negatively charged ion when it gains 1 electron, and the name for this ion changes to chloride. So when those 2 ions come together, they join by static forces, which is called ionic bonding. So we can say that ionic compounds are held by attractive forces that exist between the positively and negatively charged ions. The positive ion is called a cation, and the negative ion is called an anion. The chemical formula shows the symbols and the ratio of the atoms, and the rule for writing the molecular formula for the ionic compounds is to put the positive ion, the cation, on the left side, followed by the negative ion, or the anion. For example, with the sodium chloride compound, we write Na first, then Cl. Another example is the compound CaNO3 2. In this compound we have one calcium, which is the positive ion. We also have an NO3 inside a bracket and then 2. This means that there are 2 of the NO3. So, in total we have 1 calcium atom, 2 nitrogen atoms, and 6 oxygen atoms. We will practice more examples in the face-to-face tutorials. Molecular compounds are formed when 2 uncharged atoms bond together. A molecule is the smallest uncharged individual unit of a compound formed by the union of 2 or more atoms. Water is an example of a molecule. Let's summarize the differences between ionic and molecular compounds. 1. Molecular compounds are formed when 2 uncharged atoms join together. Molecular compounds have fixed ratio. For example, water has the molecular formula of H2O, so you know that for 1 molecule of water, 1 oxygen is connected to 2 hydrogens. Ionic compounds form when a positively charged atom joins a negatively charged atom. Ionic compounds have crystals. For example, when we examine sodium chloride at the atomic level, we see that 1 sodium cation is actually bonded to 6 surrounding chloride anions, and similarly, 1 chloride anion is bonded to 6 surrounding sodium cations. So we can actually write Na6Cl6 to express the compound sodium chloride. However, to make things easier, we write the simplest ratio, which is 1:1 in this case. So how do we recognize which compounds are ionic and which are molecular? As a general rule in this course we can say molecular compounds contain nonmetal and nonmetal atoms, whereas ionic compounds contain both metal, the cation, and nonmetal, the anion atoms. So, to summarize Module 2, we say that matter forms everything in the universe. Under matter comes the substances and the mixtures. We discussed the differences between substances and mixtures and said that we can add substances together to form mixtures using physical change. Similarly, we can separate mixtures into substances using physical change too. The substances can be either an element or a compound. We discussed the elements and introduced the periodic table where we can get the necessary information related to the elements. Elements can join together to form a compound in what we call a chemical change. Similarly, the compound can break down to its elements in a chemical change as well. We have 2 types of compounds, molecular and ionic, and we discussed the differences in these in detail. We also have 2 types of mixtures, and they are homogeneous and heterogeneous. We also discussed the differences between those types. This is the end of Module 2. Please practice the weekly exercises in your textbook and the questions you find in your workbook. We will meet face-to-face in the tutorial session, and this will be your opportunity to ask any question or clarification.